Hello everyone, my name is Omar Suleiman and I'm an associate engineer and current electrical engineering student at Arizona State University. I have spent the past few years working hands-on in the electrical field, from industrial systems and control boards to installation and maintenance work on trains and automation equipment. Through this tutorial, I aim to bridge the gap between theory and practice, showing how electrical and programming concepts come together through real-world demonstrations using the Arduino platform. In today's lecture, I'll begin with the most fundamental exercise, the LED blinking project, which introduces the core principles of digital output and embedded control. Before we start, let's talk briefly about Arduino boards. The most common is the Arduino Uno, which is perfect for beginners. However, this one right here is a copy of it, and the reason I keep it is just to experiment with it without risking burning the original higher end board. It has a USB port, power jack, digital inputs, analog inputs, and a built-in LED on pin 13. Other models like the Keyestudio one is just the same chip but with a different design, including more components for wide purposes. For this tutorial, I will use the Keyestudio with the built-in 5500 Ethernet chip. Now let's install the Arduino IDE, the software we'll use to write and upload code to the board. Go to arduino.cc, Products, Arduino IDE, download the corresponding operating system software. Run the installer and follow the default options. Once installed, open the IDE. You should see a blank sketch with void setup parentheses and void loop parentheses. Let's write our first program. Inside setup parentheses, we will tell the Arduino that pin 13 is an output. Then inside loop parentheses, it's basically where we run our code. We will turn the LED on and off repeatedly. This basically makes the LED blink once every second. The delay 1000 means 1000 millisecond pause. You can of course change this value to make it blink faster or slower. For wiring it in the real world, let's simulate it online. You can go to tinkercad.com, log in, and open tutorials. All tutorials. In Learn Circuits, hit View All and choose the blinking LED. You can skip through all the steps. The long leg of the LED, that's called the anode, and it's connected to pin 13 through the resistor. And the short leg, which is called cathode, is connected to GND. That basically means ground. Note that every electrical component works by connecting between at least two poles, with few existing exceptions like antennas. You can click on code to see how it's coded, but here the code is in blocks, which is a higher level than C++ that we just used in IDE. Now let's move to the real-world setup. On our breadboard, connect the LED's anode to pin 13 on Arduino through a 220 ohm resistor and the cathode to GND. Then connect it to PC via the USB cord. If you don't have a resistor, the LED may still work, but it's not recommended. It limits the current and protects both the LED and your Arduino board. Now we need to establish communication between the PC and our board. By clicking on Tools, Port, select the corresponding port on your PC and run the code. Now we can see the LED blinking. Note that the built-in LED is blinking as well. We can also experiment by powering the LED directly from a bench power supply and adjusting the voltage to see how brightness changes. This is a great way to learn about current limiting and resistor selection. Usually the red colored LEDs require about 2 volts. If we were to increase this voltage, the current will increase exponentially, thus burning the LED. And that's why we need to use a resistor to limit the current. To make the project more interesting, let's add a potentiometer to control the brightness. Connect one side of the potentiometer to 5 volts, the other to ground, and the middle pin to an analog input like A0 in our case. Then we will use analogRead and analogWrite to measure the knob position and adjust LED brightness. This demonstrates how we can change circuit behavior through software without rewiring. Thank you for watching and see you in the next one.